Hi, everybody. My name is Tyler Jones, the Director of Engineering at Bigeye, and I'm excited to talk to you today about bigAI and the MCP server as of today in August 2026. When we set to make bigAI app chat, we tried to make it so that we would develop a tool that would be interactive as you move throughout BigEye's platform. What kind of problems would you like to solve? What skills would you like to see? Some skills that we imagined were creating metrics, creating referential integrity check rules easily and without handwriting SQL, catalog information without navigating, and also lineage information. Imagine being able to be in an issue and ask about the root cause analysis or affected reports. This and more are all things that we imagine doing within bigAI in-app chat. I also want to call out that we have two separate capabilities that I'll show to you today. One is bigAI Chat, and it's built for you when you use the bigAI product. It lives inside of the bigAI UI, and it's made that you can ask a question in plain language and use natural language, just how you think about things. It's made to interact with bigAI's tools inside of our catalog, issues, lineage, and other products. And you can do many things through bigAI chat that you would do inside of bigAI's UI. The MCP server is a little bit different. It is a server that integrates with your AI agents, whether using tools from OpenAI, Anthropic, or other tools. It's made for use by AI agents that expose configuration for MCP clients and uses programmatic agent-driven access to access bigEye. The agent can drive accesses to bigEye to perform common bigEye operations. It uses an open protocol called MCP, known as the Model Context Protocol. The MCP server is advantageous because tools that connect to bigEye with an MCP server may also connect to other tools that are in your data or other company technology tools and allow you to access a much broader range of tools while also interacting with bigEye. Within the tools themselves, bigEye Chat and bigEye using the MCP server have many similar skills for accessing bigEye's data. I'm going to show you a little bit of each of these things today. First, I'm showing you here in our bigEye catalog where I am viewing a new table. This is a table that I just barely created in our Snowflake warehouse, and actually it is a database view. It's a view upon many configuration settings that we have within our farm being set by our users and being used every day. As you can tell, this table has no monitoring place for it already and has no issues. What I want to do is come here to bigAI, um, which I can access on the left side. So let me show you where it lives in the navigator here. If you expand, you can see it says bigAI chat. When it's collapsed, it usually stands out because it has this multicolored icon. When you click it, it will show on the right side of your screen. Up at the top, there are tools to close it, to view your history, meaning your past conversations with bigAI chat, and also start a new chat if you would like to start fresh. This chip right above the input tells you the context for your conversation, and it shows that I have as context my dim config table. I'm going to come here and I'm going to ask it, what can you tell me about my table? When I type this, it's going to assume that my table means dim config. After pulling up some details, it can tell me that it's a view, it can tell me the location, and that it's in Snowflake. It knows some things based off of what it knows from Snowflake, like the number of queries in the latest period. It knows that it's pretty low usage right now, and that it's relatively quiet in terms of popularity. It can tell me other things like schema changes, and it also is quick to tell me that there are no metrics deployed yet. It notes that I may want to do things such as set a row creation time and create metrics for these. Let's start with item number one that it says and set a row creation time. You help me set a row creation time. What possible columns may I want to use? When it does this, it'll do a lot of the same things that you do when you use bigAI, which is look at the timestamp columns that might be available to be a row creation time. In this case, I'm going to do something actually pretty clever. I have the DBT model that I use to create this table inside of Snowflake. I'm going to copy the raw file and I'm going to tell it and say, I actually have the DBT model for this table. Can you help me decide on a column to use? And so it's very long, but I've actually pasted the entire thing into the chat. And we'll see if it comes back with a useful recommendation for me. You can tell that it grabs some insights about what columns are there and how often they're likely to be changed. It notes some that are rarely changed, some that are more dynamic, some that might even be null. It's giving me some reasons for why it recommends using the default updated at column. And it asks me, ready for me to set that as the row creation time? Yes, please set default updated at as the row creation time. Since I'm using natural language, you'll note that it's even able to override some of my typos in here. So it prompts me with an action to perform this. Every time that bigAI chat needs to write to your data, it will ask you to approve or deny that transaction. In this case, I'm going to click approve. So wait, it notes done and notes that it is now the row creation time. It says now we're set to deploy time-based metrics. So we're going to ask it, can you please create a freshness metric for me on this table? Here we go. It's setting up a freshness metric. It, as part of this, gets the applicable metric types for the table, retrieves a metric configuration for it, and sets it up with auto thresholds. It then prompts me with a chip confirming the entire configuration for this metric that it's going to create. I'm going to approve it. Okay, it notes that it's been created and the configuration for it that it's created. I'm going to ask it to run it now so we can get that started. While it's running, I'm actually going to go and note that we now have one monitor here. And when we come here to the page, we need to click to run. So it's now running that freshness data. We're going to come view this. And we'll wait to see that it has run. Okay, perfect. It's run. Let's refresh our graph so we can see. Okay, here we go. So we can actually see here that it looks like the latest update is 5 days ago. And we're actually going to come back to that in a little bit because that's something that I find a little bit concerning. But before we do that, there actually is one more thing that I would like to add for this. I noted that we want to be able to build easy referential integrity checks. So I've noted that this dim config table takes in data that shares a table in common. This table shares a config key column with the table dim config defaults. Can you write a monitor to make sure that all of the config key values in this table also exist in that table, thereby ensuring a default? So it properly identifies that a custom SQL rule is the right place to check for this. And it immediately jumps in to ask, how often should this rule run? I know that the DBT propagation only runs every so often. And really, I think that it's okay if we check for this daily. It's going to prompt us now to create a SQL rule. You'll note that it shows a lot of the important information, and if we want, we can click to view the exact SQL that it's going to use. I'm going to click Approve to create this SQL rule. Okay, the rule has been created. So this will help us catch data integrity issues when they occur. Let's change gears a little bit and let's go look at some root cause analysis on an existing issue. This is an issue that I have that is looking at a value that is too low on a price per unit in a demo table that we have. You can see here on the graph that it obviously dipped very, very low in recent times. This is a status triage issue with no assignee in priority medium. We can see a lot of information here, but it's really important to note the bigAI chat can tell us many of these things. In this case, I actually want to start working on this issue. So I can ask it, please mark this issue as acknowledged. In this case, it will give me a confirmation to mark it as acknowledged. When I hit approve, this issue should be updated. You'll note that as part of the normal acknowledgement, it mutes it for 1 day. It does also, at many points, offer me more context on this thing. It's a medium priority issue. It's currently alerting with a snooze applied. It also notes that it's impacting a CEO dashboard and notes naturally that this is a thing that we may want to keep an eye on. I'm now going to ask it to assign it to me. I did note my user ID because, full disclosure, I did note that there was a bug sometimes where it did not associate the ID. That bug should be fixed later today. When I click approve, it should also assign the issue to me. Perfect. Now let's ask it a little bit about the information in this ticket. Let's ask it what the root cause is. And it shows that it can be traced back to a different orders table in an Oracle warehouse that is not this Snowflake warehouse. It still doesn't know why it's behaving that way, but it does note that there is a root cause upstream. It also knows what is downstream, which is also important. Similarly, Big AI would help us that if we were looking at the CEO dashboard, we would be able to ask it what issues may be affecting it in that moment, which is also an important thing to get. With that done, I want to show you now a little bit our MCP server. Hold on as I bring up a different application. Okay, now we're looking at Cortex code, an application distributed by Snowflake. Snowflake Cocoa or Cortex code can be configured with BigEye as an MCP server. With this tool, I can do normal things inside of my Snowflake workspace, but also I can consult BigEye as an MCP server for information. For example, I can tell it to please find, mine, and config. Can ask it to find my table so we can have a little bit of context for our conversation that we're about to have. So you'll notice that it looks for it in my Snowflake account, not just inside of BigEye. You'll see it finds various instantations of this dim config table, along with the dim config defaults that we had been looking at before. There are also some useful things that I can do here. Let's start another session. I can still ask it what BigEye issues are assigned to me. So you'll see it will run various BigEye MCP calls to get the current user and then to search through issues. It's very adaptable, so even if it makes an erroneous request, it will eventually figure out the right way to query the API and get you the data that you need from BigEye. In this case, it actually seems to be struggling filtering issues by assignee. And actually seems to be struggling even though it's found my ID. So putting that aside, we're going to go and just query about a specific table. You'll see it's actually able to look up the table and then look up the issues specifically for that table. So let's see what it finds. In this case, it's actually taking quite a while to triangulate the table, the schema, and find the actual issues for it. It's dancing around a little bit. Can see that it saw in the tool that it found the issues and then discarded them and then came back to them. Now, it finally found my issues and it's showing them in a nice table. It decided to format them by priority, by summary, by column, and the alerts. It usually makes some pretty good insights on this, like the high priorities that it's noting. And it also notes the number of alerts on the freshness issue. Let's see, which one do we want to zoom in on? Let's look at one thing that I can tell right away is that those two freshness issues look really related. So in this case, we'll actually take the freshness issue and then we'll actually run a query inside of Snowflake to be able to verify the freshness is in fact off. This may help us to determine if this is something that is worth working on. So it found the model expected freshness and that it's 5 hours stale. However, it was actually closed as a false positive. Then it was reopened and then it was auto closed. It actually looks like the table's freshness is actually healthy right now, and they can tell that DBT ran about an hour ago. This issue was a false positive. I'm now really curious if this issue closed. Okay, it is close. It appears that in this case we're looking at an old issue, which maybe would have been helpful starting out. So now I feel like I need to clarify which of the issues are still open. And now we find out that they are all closed. If I had been reading earlier in this conversation, it seems like it may be clear that I may have needed to read a little bit more closely. So let's ask you now which issues are open and high priority. So now we see there are 257, none in the first page that are high priority. So now it's trying to filter and find any that are high priority. It's finding a lot of low and medium priority, but no high priority ones. So it's going to keep searching. But it is noting some really notable low and medium that might be good to start on first. They are assigned to someone else, but that wouldn't necessarily hold me back from working on them. This is to show you a little bit about how you can work inside of Snowflake and also work with Bigeye. I think the thing that's most important here, aside from my failures in interacting with the issues list directly, are that we can use this alongside Snowflake to actually query tables and diagnose problems while also working in Bigeye to look at the issues list itself. I hope this was helpful today.